Hey scholars, we're going to talk about the law of detachment and the law of syllogisms. Now this is all based still off of using conditional statements, and remember we need to know what those are. Now let's think about it. Can anyone probably tell me what a conditional statement is? Well, first of all, let's remember what it is. It is an if-then statement. And we use the symbol here, if P then Q, and we use that arrow to represent that. Now remember what a conditional would be, like if today is Monday, then tomorrow is Tuesday. I mean, kind of a common sense, yeah, Gregerson, that makes sense type scenario. So if today is Monday, then tomorrow is Tuesday. Now what about the next one? Hypothesis and conclusion. What's the hypothesis part? Well, remember the hypothesis is the if part. It's the start. The conclusion is the then. So here, my hypothesis would be today is Monday, and then my conclusion would be tomorrow is Tuesday. Now, how in the world do we get the converse of a conditional statement? Because all it does is it makes a new one. Well, to get that, you switch the hypothesis and conclusion. All right, so we switch the hypothesis and the conclusion. Now we have what's called the inverse. Now how do I do the inverse? Well, I look at my original conditional statement and then I negate both the hypothesis and conclusion. And we use these really fun little symbols. We made it look something like that. And then we knew the converse was when we switched them around. We let our visual aids help us. Then we have what's called a contrapositive. And when you have a contrapositive, you switch both the hypothesis and conclusion, and you negate. Or you negate and switch. It doesn't really matter which one's which. So when I do that, I get not Q, then not P. And then I have my biconditional. What's the biconditional? It's an if and only if statement. Now this is only works sometimes. You only use this once in a great while. Only if the converse is true and your conditional is true to start with. So you have to have two things true or we can't use it. Now, when can a person write a biconditional? When the conditional and converse are both true. And I end up stating that twice because I get my work ahead sometimes without completing what I was working with. Now, we are going to use what's called deductive reasoning. Remember, inductive reasoning is reasoning based off patterns. Remember, deductive reasoning, and it should be V here, right? Deductive reasoning is using let me read how that says that sound real. So we're going to apply deductive reasoning using two rules of deductive reasoning. Now, I thought my stuff wasn't totally as crazy as I thought. Now, here's the thing. The two rules are called Law of Detachment and Law of Syllogisms, and they're very common sense ones. Don't over freak out what they are. I'm going to show you symbolically, but I'm going to show you how they work. Now, here's the hint. If you want to do well on the test, really make sure on this section, really make sure you know the examples well. I'm not going to throw really huge or different things at you on your test. So, remember, deductive reasoning is rules-based. You use rules. So everything we're going to do is we're going to be rules-based today. And the first one is called the Law of Detachment. Well, the Law of Detachment is the following. If a conditional statement is accepted as true, so if a conditional is true and its hypothesis is true, then the conclusion is true. So if the hypothesis is true, then I want the conclusion to be true. So here's kind of what you want to think about symbolically. Here's my conditional statement. If P, then Q. If my hypothesis accepted as true, I can naturally conclude Q. Now, it can be flipped around. I could have my statement of truth by itself then I can have my conditional statement, but I still come up with the same conclusion. Here's what I mean by this. Let's read this with me. If M is the midpoint of a segment, then it divides the segment into two congruent segments. Well, M is the midpoint of segment AB. Well, if M is the midpoint, what is it going to do? That's right. I'm going to get the fact that I know segment AM is congruent to segment MB. I'm going to get two congruent segments. Why? Think about this for a moment. Here's AB. M's the midpoint. Right away when I have an endpoint, I can assume I have two congruent segments. Now let's look at the next one. If a baseball player is a pitcher, then the player, boy, I have a lot of typos on this, the player should not pitch a complete game 2 days in a row. Well, Nick is a pitcher. On Monday, he pitches a complete game. What can you conclude? All right, Nick's a pitcher, and he pitched a complete game. What can you conclude? First of all, you should think about, yeah, Nick shouldn't pitch 2 days in a row, correct? Yeah, so he shouldn't pitch 2 days in a row. So what are we going to do instead? We basically would say, and this is the Beck's one, Nick shouldn't pitch on Tuesday, right? So the nice thing is, we know he pitched a complete game, then we know he shouldn't pitch on Tuesday. Now, those are some kind of examples. Let's do some better ones I like a little bit better. Right here. A gardener knows that if it rains, the garden will be watered. It is raining. What does the gardener know? The garden will be watered. I mean, it's kind of a common sense thing, but it really does kind of build. Here's another one. For the given statements, what can you conclude? If angle A is acute, then the measure of angle A is less than 90. Angle A is acute. What can I assume? I know the measure of angle A is less than 90. It's like you're repeating it. Like, I know this is my conditional statement. This tells me it's for sure an acute angle. Well, then I therefore know the measure of it is there. All right? So then I try the next one here. It says, if a triangle has one 90-degree angle, then the triangle is a right triangle. In triangle DEF, the measure of angle E is 90 degrees. Well, does the triangle have a 90-degree angle? Yeah. So therefore, what is it? Yeah. Triangle DEF is a right triangle because it has one right angle. Now, sometimes we can misuse law of detachment. It's possible to use the law of detachment to draw a conclusion. If it's not possible, use this law to explain why. Look at the next one. It says, if a road is icy, then driving conditions are hazardous. Driving conditions are hazardous. All right, can I use it? No, I cannot. No. Because what do we don't know? We don't know if the hypothesis is true. All right, we understand that the conditional is true, but I'm not sure about the hypothesis. So here's what I mean. Look here. It says the road is icy, the driving conditions are hazardous. Oh, look, the driving conditions are hazardous. Does that necessarily mean the road's icy? No. So I can't make that assumption. All right, so we'll talk a little bit more about this, and we'll do some examples here with our homework. But we're going to do the law of syllogisms first, or I call it the law of syllogisms next.